Okay, this will be the review video for practice test number 4. Remember that this covers the chapter 9 sections, the chapter 10 sections, and then 3.3 as well. So we're going to get started. I will have to use scratch paper probably for a lot of it because there's just not going to be room on the printed off test or the printed off practice test as I have it. So, all right, let's get going. It says determine which, if any, of the following ordered pairs satisfy the given system of linear equations, and then it gives us the system right over here. Remember, these are plug and chug style problems. You have to test all of them because it says find which, if any, which means we're going to have to test all of them. And remember as well that it has to work for both equations in order to work for the system. If it doesn't work for one equation, then it doesn't work for the system, and you can move on. So first one we're going to do is the negative 227, and we'll plug that into the top equation of 5x plus y equals 17. Plugging in the negative 2 in place of the x and the 27 in place of the y, and seeing what we get out. 5 times negative 2 is a negative 10, plus 27 equals 17. Negative 10 plus 27 is 17. This is what we're looking for. That worked in that one. That doesn't mean that ordered pair works for the system yet. We have to test it in the second equation of 2x plus y equals 26. And if it works in that one, then it works for the system. So 2x plus y equals 26. Again, anywhere there's an x, I'm going to put a negative 2. Anywhere there's a y, I put 27. And then I do the calculation to see if it works. Negative 2 times 2 is negative 4, plus 27 equals 26. Negative 4 plus 27 is a 23, and that does not equal 26. So it did not work for the second equation. So negative 227 does not work for the system. So we've eliminated that one. Now we'll try 13, 0. And again, we're plugging them in the same equations, the 5x plus y equals 17. 5, anywhere there's an x, I'm putting 13. Anywhere there's a y, I'm putting 0. 5 times 13 is 65. 65 plus 0 is 65. That does not equal 17, obviously. So actually, we're done at that point. We don't even have to check 13, 0 in the other equation because it already doesn't work for this equation, so it doesn't work for the system. So then we can move on to 3, 2. 5x plus y equals 17. Anywhere there's an x, I'm going to put a 3. Anywhere there's a y, I put a 2. 5 times 3 is 15. 15 plus 2 is 17. So again, 3, 2 worked in the first equation, so we're good there. Then we try it in 2x plus y equals 26. Anywhere there's an x, I'm going to put a 3. Anywhere there's a y, I'm going to put a 2. 2 times 3 is 6. 6 plus 2 is 8. 8 does not equal 26, so once again, it doesn't work. So that one didn't work for the system either. So we've tested all 3 points, and one of our options is none of the ordered pairs satisfy the system. That would be our answer because none of them worked for both equations. Moving on, it says determine the solution to the following system of equations graphically. And then if the system is dependent or inconsistent, state so. Remember, dependent means that the lines lay right on top of each other and it looks like one line when we're done graphing it. Inconsistent means that they are parallel lines and they do not cross at all. Otherwise, they will cross at a specific point and we will be able to see that on the graph. Excuse me. So the first line, it says y equals x plus 4. I'm going to make notes that the first line has a slope of positive 1. Because there's no number written in front of the x, so we understand that to be a 1, and the y-intercept is 0, 4. The slope for my bottom line is negative 1, and it has a y-intercept of 0, negative 4. So remember the way we graph these is we graph the y-intercept, and then we use the slope in order to graph the next line, or next point, excuse me. So the top line is 0, 4, so I go up to the 4, plot that point, and then a positive slope of 1. So remember, if it's a whole number, you can make it a fraction by sticking it over 1. And then if you have a 1 on top and a 1 on bottom, and they're both positive, the top number is your vertical direction. The bottom number is your horizontal direction. So that means from this y-intercept, I'm going to go up 1 over 1, and that's where I drop my second point. And then I connect them as best as I can on here with a piece of paper. On Pierce, see, even with a piece of paper, I can't draw a straight line. There we go. Excuse that little tail mark that's sticking up right there. All right, for the next one, I have 0, -4, so that's down here. But then it has a -1 slope. So again, it's a whole number, so you stick it over 1. The top number tells you vertical direction. Since it's a negative vertically, that means you're going to go down. The bottom number is a positive, so again, that takes us to the right. So from this y-intercept, I'm going to go down 1, right 1. And hopefully even with my, yeah, it'll be good, self-drawn lines, we will be able to see exactly where they cross, because they should cross at a nice, neat point. And look at that, they do right there at the point -4, 0 is at an x-intercept. So that's what I type here is -4, 0. Because I didn't have a dependent or inconsistent system, I had a consistent system, and it crosses at -4, 0. Okay. Number 3 says determine the solution to the system of equations by substitution. It says x equals y minus 1, and then 4x minus 2y equals 8. Remember, with substitution, we get one of our variables by itself, like this one, the x is by itself, so x equals y minus 1. So we're going to take that and we're going to plug it into the second equation in place of my x. That's the whole premise of substitution. So I'm going to do the work down here. I'm going to slide up a little bit. So instead of 4 times x, that top equation says x is y minus 1. So I substitute that into the second equation. Then I finish writing the equation exactly as it originally was. Now I have one equation with one variable, and I'm going to solve for that variable. I distribute. So I have 4 times y, which is 4y. 4 times -1 is a -4. 4y minus 2y is 2y, combining those like terms. I got to get y by itself, so I'm going to add the 4, and I have 2y equals 12. Divide both sides by 2, and I find that y equals 6. Now, that's only part of my answer, because I need to figure out what x is. But according to that top equation, x equals y minus 1. So I can take this y is 6, and I can plug it in to that equation to figure out what x is. X equals y minus 1, but we just said y is 6. So x equals 6 minus 1, which is 5. Now we're going to write that as an ordered pair. X comes first, so that'll be 5, 6. We're being careful to make note of the fact that if we have to type an ordered pair, we have to put it in parentheses. If you don't have parentheses, it's no longer an ordered pair. All right, we have another one via substitution. 4x plus y equals 5. 4x plus y plus 7 equals 0. Now, I can show you a little trick if you'd like to see a little trick. Notice that both of our equations have a 4x plus y. Do you see that? The top equation tells us that 4x plus y has to equal 5. So we could actually do like a big substitution if you wanted, where we take the 4x plus y and the 4x plus y. So instead of writing 4x plus y in that bottom equation, it tells me in the top equation 4x plus y is 5. So I could just say 5 plus 7 equals 0, because see, it says 4x plus y plus 7. Well, 4x plus y is 5. So here, 4x plus y, I plug in 5. 5 plus 7 is 12. 12 equals 0? I don't think so. That means there is no solution. Now, could you do it the longer way like we just did the last problem? Sure you can. I don't want to. So that's the little trick you can do, is if it works just like that. If you needed to, you wanted to work the long ways, what I would do is on this top equation, I would get y by itself by subtracting 4x over. That way y equals 5 minus 4x. Then I would stick that into the bottom equation and do the substitution. You're still going to get the fact that there's no solution. It just takes you a little bit longer. But if you like one method and you don't want to see the little tricks, that's what you would end up doing. All right. Number 5, again, says substitution. And luckily, they're nice enough, and they say y equals 1/4 x minus 4. So they already have one of our variables isolated for us. So I can take that 1/4 x minus 4, and I can plug it into the second equation in place of my y. So instead of x minus 4 times y, I'm now going to have 4 times 1/4 x minus 4, because that's what y equals 16. Now, in order to solve, I'm going to have to distribute that -4, not just the 4, but the -4 inside the parenthesis. So I have x, and then -4 times 1/4, excuse me, -4 times 1/4 will just give me a -1. -4 times -4 gives me a positive 16. And then look what happens. We have x minus x, those go away, and we're left with 16 equals 16. This is a true statement. Up here, we got 12 equals 0. That's a false statement, so we had no solution. Here we have 16 equals 16. That always happens. Like 16 cannot equal anything but 16. That's what the number is. So that means there's infinitely many solutions. Those are the two differences you can have. Actually, we've seen all three of them now. Because over here, we did substitution and we got a nice ordered pair. Up here, we did substitution and we got a false statement, meaning there's no solution. And here, we did substitution and we got an always true statement, which means there's infinitely many solutions. Number 6 just tells us to solve the system of linear equations. It doesn't actually give us a method they want us to use. I will tell you, don't get confused by this 1 and 2 right here. I don't know why some of the problems do this, but some of them just label the equations for you. They don't have any other purpose. Don't try multiplying them. Don't do anything with those numbers. They're just telling you this is equation 1 and this is equation 2, and I don't know why they do that. So I'm just going to mark it out and pretend it doesn't exist. So this is our equation, or our system of equations, and we can solve this either with substitution like we did the last 3, or the addition method. And I'm going to tell you the way that it's all lined up, and the fact that one of my variables is positive and one of my variables is negative, that makes me want to do the addition method. Because if I add these as they sit, my y's are going to go away. And remember, that's the point when we do the addition method, is we want one of our variables to go away. Because if I add straight down, I'll have 2x, my y's cancel, and that equals 14. Divide both sides by 2, and you find that x is 7. And then I can take this and plug it into either one of the original 2 problems to figure out what y is. I'm going to just go with the top one, which is x plus y equals 9, and I'm going to take that 7 and plug it in. So that I have 7 plus y equals 9, subtract 7 from both sides to determine that y is 2. So my ordered pair, the x term comes first, which is 7, comma 2, inside of the parentheses. All right, the next one says we have to use the addition method. So we have negative 4x plus 4y equals a negative 22, and then we have 5x minus 2y equals 44. Now, just like on last one, when we add them together, one of our variables needs to go away. If we add them right now, none of our variables go away. So here's how I kind of determine which one I'm going to delete, or which one I'm going to use to cancel. First thing I'm going to do is say, do my variables have opposite signs? Because that makes my life a little bit easier. And in this case, they both do. The x's are opposite signed, the y's are opposite signed. Then the next question I have to ask myself is, can I multiply one of the numbers in front of my variables by a constant to turn it into the other one? Like, can I multiply 4 by something to give me 5, and I wanted to think about whole numbers? And the answer is no, I can't. Can I multiply 2 by something, though, to give me 4? And the answer is yes, I can. If I multiply this equation by 2, that will give me a negative 4y, which would cancel with my positive 4y in that top equation, and that's what I need to have happen. So I'm going to rewrite that top equation exactly as it is, mostly because I don't have room over there. And then the second equation, I multiply everything by 2. Not just the y, but everything. So 5x times 2 is a 10x. The negative 2y times 2 is a negative 4y. And then the 44 times 2 would give me 88. Now it's ready for me to do my addition. Negative 4x plus 10x will give me a 6x. My y's cancel out completely. And then I have a minus 22 plus 88. That gives me a 66. Divide by 6, divide by 6, and I find that x is 11. So now I can take that and plug it into either one of the originals in order to come up with my y. I'm just going to stick it in the top one. It really doesn't matter which one. It's totally up to you. So if x is 11, that'll be negative 4 times 11 plus 4y equals a negative 44. Negative 4 times 11 is negative 44. Whoops. I don't know why I wrote 44 over there and I meant 22. Sorry, guys. Now I add the 44 to both sides. And I get 4y equals negative 22 plus 44 is 22. Divide by 4, divide by 4. And I get y is 22 over 4. But both of those are even, so it's not simplified. 22 is 2 times 11. 4 is 2 times 2. So those cancel, meaning I have 11 over 2 as my y value. Fractions are totally okay. They just need to be simplified. So my x value is 11. My y value is 11 over 2. Do not give a decimal. You don't give a mixed number. Always give simplified fractions, whether they're proper or improper. All right, come up here, sorry. Don't look, because I'm scrolling. I'm moving the paper around, but that could give you motion sickness if you have an issue with that. All right, this one also says do the addition method, so we will do that. Notice as they sit right now, if I add them, my x's don't cancel, my y's don't cancel. So I'm going to try and do the same thing I did on the last one, where I multiply one of my equations by a constant so that one of my variables cancels out. First thing I notice is that I have a negative 9x and a positive 45x. I know that if I multiply 9 by 5, I'm going to get 45. So if I multiply this whole top equation by 5, my x's are going to cancel out, and that's what I want to have happen. So I'm going to multiply the whole top equation by 5 so that I have negative 45x minus 15y equals a negative 30. The bottom equation stays exactly as it is. I'm just rewriting it because I had to move it over here. And then I do my addition. Negative 45x, positive 45x, those go away. A negative 15y and a positive 15y, oh, those go away as well, so I'm left with 0 on the left side. Negative 30 plus 31 gives me a 1. 0 equals 1? I don't think so. So that means there is no solution. All right, let's look at our landmass problem. I'm probably going to work this on scratch paper just to make it a little bit nicer. It says the combined land area of countries A and B is 142,973. So remember, that word is where you put an equal sign. So that means if I take the land of A and I add to that land of B, I'm going to get the 142,973. That's what that first sentence says. I just made an equation out of it. Second sentence says country A is, so I'm going to write country A is larger by 373 square kilometers. If it's larger, that means I take country B and I add to that 373. Determine the land area of each country. Well, right there I have two equations, two unknowns. That's a system of equations. And on top of that, A is B plus 373. What that means is I can substitute B plus 373 in place of my A in my first equation, and I can solve because I will have one equation with one variable. Instead of A plus B, I'll now have B plus 373 plus B equals 142,973. One equation, one unknown. We can solve that any day of the week. We have common or like terms with B and B. That'll give me two B's. Plus 373 equals 142,973. To get B by itself, I'm going to start by subtracting 373 from both sides. And I get 2B equals 142, nope, that'll be 700. Sorry about that. Divide both sides by 2, and I find that B is 7,1. What is it? Mental math. I don't want to get it wrong because I'm being recorded. Divided by 2. Okay, I was doing it right. 350. Just seemed a little wrong. Did I do the subtraction right? Because according to my answer key, that's not what I should have. So maybe I did my subtraction wrong. It is. I did. You guys should have yelled at me. That's a 6. That's a 6. 9 minus 3 is a 6. See, I make mistakes too. Because that should be a 0, 0. Obviously, you can't yell at me because you're on the other side of the computer screen. But if you could have, you would have said, teach, 9 minus 3 is 6. And you would have caught that. So the land area of country B is 71300. 71300. I'm just writing that in up here in my answer spot. Now that I know what the land mass, or the land area, excuse me, of country B is, I can take that and I can plug it in right here to figure out how big A is. Because A is whatever B is, plus 373. So 71300 plus 373 is going to tell me how big A is, and that'll give me 71673. That's how big country A is. 71673. Again, you can do a little bit of a logic check here, in that if you do this problem and somehow when you're putting your answers in, country A is smaller than country B, we've done something wrong. So you can do a little bit of a mental check. All right, we got some bird seeds. This is a mixture problem. These are really straight out of chapter 3.4, which we did earlier in the semester. It's just now we have systems of equations, so we don't necessarily have to use the table if we don't want to. If you like the tables that we did in 3.4, you can totally use the tables here and still come up with the same system of equations. It says birdseed costs 59 cents a pound, sunflower seed costs 89 cents a pound. Angela's pet store wishes to make 30-pound mixture birdseed and sunflower seed that sells for 76 cents per pound. How many pounds of each type of seed should she use? So, I'm going to do this without a table because you've seen me in past videos do it with a table. So I want you to see how we would build this up without a table. What you're going to do for your two equations is you're going to have an equation that has the money amounts, and you're going to have an equation that has just the amount of pounds. Okay? So here's what's going to happen. I'm going to say B for bird seed, S for sunflower seed. The amount of bird seed we have plus the amount of sunflower seed we have, it says that they want to make a 30-pound mixture. So once I'm done mixing these things together, I need to end up with 30 pounds. That's my first equation right there. Bird plus sunflower equals 30. Now, the way we come up with our next equation is we use this as a starter, but we put the amounts that each of these things costs in front of it. So what do I mean by that? I mean that bird seed, how much did it cost? 59 cents a pound. So I do 0.59 times B. Plus, how much did sunflower seed cost? 89 cents a pound. Equals, how much do they want the mixture to sell for? They want it to sell for 76 cents a pound. And that's times 30, not times M for mixture, because we actually know how many pounds of it we're supposed to get. This is how we come up with the equations without using the table. Now, they want to know both of these, so it doesn't matter. We have two equations. Each equation has two unknowns. I'm going to do substitution. What I'm going to choose to do is I'm going to play around with this first equation. I'm going to get B by itself, and the way I do that is I subtract the S over. So that way I have B equals 30 minus S. Now I'm ready to actually do the substitution method, where I take the 30 minus S and I plug it in to my second equation. So I'll have 0.59 times B, but B is 30 minus S, plus 0.89 S equals, and then just so that we save some time, I'll go ahead and take 0.76 times 30. That's 22.8. 22.8. I have one equation now with one unknown. S is what I'm looking for, and this one as I have it written right now. I'm going to distribute the 0.59 to get rid of that parenthesis. 0.59 times 30, 17.7. 0.59 times negative S is negative 0.59 S, plus 0.89 S equals 22.8. I have some like terms here, and then I have negative 59s and a positive 89s. That means I'm going to have a positive 0.30s equals 22.8. Subtract 17.7 from both sides. So I have 0.30s equals 22.8 minus 17.7 to give me a 5.1. Divide by 0.30, divide by 0.30 to find that I need 17 pounds of sunflower seed for this mixture. And I'm going to go ahead and write that up here. And we're going to pay attention. It actually is asking us for bird seed first, but I just found sunflower seed, so I'm going to write it down here. And the nice thing is that now I know how much sunflower seed we have. I can take that and plug it in because bird seed is going to be 30 minus the sunflower seed. So B is 30 minus S, but S is 17. So B is 30 minus 17 is 13. We need 13 pounds of bird seed. Now again, I did this problem without a table. You can totally still use the tables from 3.4 that we've always used. You would still get the same equations out. They would come out of your pounds column and out of your last column. That's exactly where we get them. It's up to you whether or not you choose to use the tables any longer. Solve the inequality and graph the solution on the number line. So remember, when you're solving inequalities, it's just like solving equations with one special thing. When you are multiplying or dividing by a negative across your inequality symbol, then you flip your sign. Otherwise, all the same rules apply to our inequalities as our equations. So if I have a negative 3x minus 5 is greater than 19, I'm going to focus on getting x by itself. To do that, I would add the 5 to both sides. So I have a negative 3x is greater than 19 plus 5 is 24. Divide by negative 3 and divide by negative 3. And right there, I'm going to draw big attention to the fact that I am dividing by a negative across that inequality symbol. So I'm going to have to flip that sign. So it's going to be x instead of greater than, it's going to be less than, and then 24 divided by negative 3 is a negative 8. That is what I'm going to write in my answer box because it says type an inequality. X minus 8, negative 8, excuse me, x is less than negative 8 is an inequality, and that's what I would type in there. Then I look at my graphs and say, okay, which one is it? Well, I know it's not B, and I know it's not C because those are everything and nothing. Everything else does have a negative 8 on it, but I need to be less than negative 8. So that means to the left of, so that means I'm either going to be E or F. I have to be because those are the only ones left of. Now, E has an open circle, F has a filled in circle. Since it's strictly less than, I need to go with the open circle situation. So my answer is E. F is for if I had the equals to line underneath it, which I do not have. All right, the next one says solve the inequality and give the solution in interval notation. So this time they don't want inequality, they want interval notation. And this is a complex inequality because you'll notice we have 3 different parts to it. And that's okay, we can actually solve this the same way we solved the other one. It's just instead of doing it to 2 sides of our inequality, we do it to 3. It's like having a 3-sided equation. My goal is always to get the variable by itself. The only thing connected to that variable is an 8. It's being added. So the opposite would be subtract. So I subtract 8 from the middle, but if I do it from the middle, I got to do it from the right, and I got to do it from the left. Subtracting across your inequality symbols does not flip them at all. So we have a negative 5 minus 8, that's a negative 13, is less than or equal to t, which is less than 9 minus 8 is 1. If we wanted, or if they wanted an inequality, we would type that in, but it doesn't say that. It says it wants interval notation. So interval notation is where you put your lower limit on the left, your upper limit on the right. Since negative 13 is less than or equal to t, the negative 13 is your lower limit. Now, the less than or equals to tells me I have to use that squared off bracket. And then I list my lower limit, comma, I go up until my upper limit, which is 1. Now 1 though there's no equals to aspect to this. So if there's no equals to, there's no line underneath our symbol, we use a parenthesis. So squared off bracket, negative 13, comma, 1, parenthesis. And we get to do it again on the next one. It says solve the inequality and give the solution in interval notation. I'm going to rewrite it down here because there's more space. I have 15 is less than 5 minus 2g is less than 20. Same concept to what we just did. I'm trying to get my variable, which is g in this case, by itself. So what I'm going to do first is I need to move the 5. So the 5 is positive, so to move it I would subtract 5 from both sides. 15 minus 5 is 10. That'll leave me with a negative 2g in the middle, and 20 minus 5 is 15. Now, this is where it's going to get interesting because I have a negative 2 times g, so to get that away from g, I got to divide by negative 2 everywhere. But hopefully alarm bells are going off because I'm dividing by a negative, which means all of my signs are flipping. 10 divided by negative 2 is a negative 5, so instead of less than or equal to, we now have greater than or equal to. G, instead of less than, we have greater than. And we have 15 divided by 2, so that's just a negative 15 halves. Those are already simplified. We're not doing decimals. Now, the problem is, and hopefully you can see it because you can still see our answer up here. Notice this said negative 13 is less than or equal to t. We have negative 5 is greater than or equal to g. This is not a lower limit. This is our upper limit because negative 5 is bigger than g. And g is bigger than negative 15 over 2. So the negative 15 over 2 is actually our lower limit. So we have to be really careful. We need to write the negative 15 over 2 first because that's our lower limit on the left. And it's strictly less than, so I'm going to have the parenthesis, comma, and I go up until my upper limit, which is negative 5, and because it has the equals to, I have that squared off bracket. So this one's, you got to be careful. It's not always how it's written here. You have to actually read what your symbols are telling you. The lower limit is the smallest value g can be. Negative 5 is not that value because negative 5 is greater than or equal to g. So you got to be careful on how it's worded. And you will get it wrong if you put the negative 5 on the left, comma, negative 15 over 2, because the lower limit always has to go on the left. So just be careful as you do these problems. All right, now we're going to graph some inequalities. This is y is greater than 5. So remember the nice thing about graphing inequalities is that we really graph them the same way that we would graph linear equations, with one exception. Well, actually, I guess there's two exceptions. The first one is that if we are dealing with strictly greater than or strictly less than, without the equals to, we're going to use a dashed line. Then we have to do a test point to figure out where we're going to shade. So sometimes we use dashed lines, sometimes we use solid lines. We always will have one section shaded. That's the difference. So y is greater than 5. Think about this as a y equals 5. If that was a linear equation, that would be a horizontal line at the value of 5. So that's still what we're going to graph, but because it's strictly greater than, we're going to use a dashed line. And I hope this will show up on the paper as much as possible. Maybe I'll use this pen. It's a little bit thicker. So I go up to 5 and I start putting a dashed line in. On Pearson, when you click your line tool, you can select either solid or dashed lines. And here's the nice thing. If you accidentally graph with a solid line and you realize, oh crap, I need a dashed line, click your line and then you can click the dashed part and it will change it for you. So don't freak out too much. Okay, now I have to shade. This one's a little bit easier, so I'm just going to kind of talk you through it instead of doing a test point. Y has to be greater than 5. So this is the line we just drew. Look at the values of my y up here and my values of y down here. Where do I have values greater than 5? Up here, because that's where 6, 7, 8, 9, 10 are. So I'm going to shade this top bit. That's where you use your paint bucket and you drop it in. And remember, be careful to only drop one paint bucket. If you accidentally drop 2 paint buckets, it will count you wrong. If you don't realize that you accidentally dropped 2 paint buckets until after you've submitted a quiz, you can always email me, but just do 1 paint bucket. All right, and that's it for that problem. Now let's do a system of linear inequalities. The way you need to approach these, the same way we would graph a system of linear equations, in that we want each of our linear inequalities to look like y equals mx plus b. Yes, I know we don't have equal signs, but we need y and then inequality symbol mx plus b. The bottom one is already written appropriately, so that one's great. We're ready to go with that one. The top one, though, we have a 2x minus y is less than 3. So what we're going to do is we're going to move that one around. 2x minus y is less than 3. I need to get y by itself, so I'm going to subtract the 2x from both sides. And I get negative y is less than, and because I need it to look like mx plus b, I'm going to put that x term first, just like this. And then I have to divide or multiply everything by that negative 1 that's connected to my y. But when I divide by a negative, I have to flip that sign. So y is now greater than, negative divided by negative is a positive 2x, positive divided by negative is a negative. So there's my top inequality, and I'm going to make some notes with it. First thing I'm going to note is that I have a y-intercept of 0, negative 3. I have a slope of positive 2, and because y is strictly greater than, it's going to be a dashed line. All 3 pieces of this information will help me when it comes to graphing them. I'm going to do the exact same thing for this bottom one, only I don't have to do any of that manipulation. I can just start taking notes. My y-intercept for it is 0, positive 3. The slope for it is a negative 1, and it's got y is greater than or equal to, so it is a solid line. That's the 3 pieces of information I need to know for graphing that one. All right, so I'm going to graph the top line first, which is the one we did down here. 0, negative 3. Plot that point. And then the slope is a positive 2. So remember, that's 2 over 1, and they're both positive. The top number tells me vertical direction. The bottom number tells me horizontal direction. So I start from this point I just plotted. I move up 2 and to the right 1, and I drop it. And then I'm going to be careful because I need to do a dashed line. So I'm going to make dashes. And I can't tell you the number of times that I've said that, and then I do a solid line. Dash, 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 dash. All right, dashes. Now I'm going to do the same process with my bottom line, which was the 0, 3. And then I have a slope of negative 1. So remember, that's negative 1 over 1. The top number tells me vertical movement, so I'll go down 1. Bottom number tells me horizontal movement, so I'll go to right 1. So from that point, I go down 1, right 1, plot that. And I get to use a solid line this time, so I don't have to worry about it. Solid line. Now, we have 2 lines, they cross. With an inequality, we don't care where they cross. We care which regions they share. So notice it cut our graph into 4 different regions. One of those will get colored. We got to figure out which one. So what we're going to do is we're going to pick a test point, and we plug it into both equations and see if it works. The one that I always start with, because it's the easiest one to test, is if neither of the lines go through the point 0, 0, I'm going to test 0, 0. Because I need to see if it's going to be true or false, and plugging in zeros is the easiest thing I can do. So I'm going to take the top one, which is 2x minus y is less than 3. I go back to the original format. I plug 0 in for x. I plug 0 in for y. 0 times 2 is 0. 0 minus 0 is 0. And then I look at it and I say, okay, it says 0 is less than 3. Is that true? Yes, 0 is less than 3. We are good to go there. Then I look at y is greater than or equal to negative x plus 3. I plug in 0 for both of them, and I say 0 is greater than or equal to positive 3. Well, that's not true. 3 is bigger. So it didn't work. So that means I don't color where 0, 0 lives. That's all I know at that point. Don't color where 0, 0 is. So I pick another test point in a different region to try again. I'm going to choose to go up top. And again, I'm going to pick a point that's easy to plug in. I'm going to pick a point on one of my axes because that makes one of my values 0. So I'm going to pick the point 0, 4, and I'm going to test it. So 2x minus y is less than 3, and I'm plugging in 0, 4. 0 for my x's, 4 for my y. So that's 0 minus 4 is less than 3, negative 4 is less than 3. Oh, you can't see that. I'm so sorry. There you go. That's true. Negative 4 is less than 3. We are good on that one. So again, it worked for the top one, but we needed to work for both. So the bottom one was y is greater than or equal to negative x plus 3. I'm plugging in 4 for y and 0 for x. 4 is greater than or equal to 3. That's true, 4 is greater than 3. Since it worked for both, that means that I shade the region up top. I don't have to test any other points. That's the region I shade. You will only ever shade one region. I don't care if you have 4 regions like down here, you have 2 regions like up here, or if you did something crazy and we had a system with 3 equations or 3 inequalities, we would still only shade one region. All right, so let's look at this one, which is number 16. 16 is an isosceles triangle problem, so immediately you need to think isosceles triangle. That's where you have 2 sides are the same length and the bottom 2 angles have the same measure. That's what an isosceles triangle means. It says one angle is 21 degrees greater than each of the other 2 equal angles. Find the measure of all 3 angles. So this one's always a bit deceptive because it says basically, you have 2 angles that are equal, each of the other 2 equal angles, and then the other remaining angle, this one up here, it says is 21 degrees greater than the other 2. What that means is it's not we're adding the other 2 together. It's we don't know what these are in the bottom, but I do know they're equal. So if I say the bottom left one is x, that means the bottom right one is x, and this top one then is x plus 21 because it says it's 21 degrees greater than the other 2. And then we have to remember that the interior angles of a triangle add up to 360. No, 180. Goodness. Let me get my math right. 180. So that means if I take x plus x plus x plus 21, I have to get 180. Well, 3x's gives me 3x plus 21 equals 180. Get x by itself, I subtract 21, and I get 3x equals 159. Divide by 3. And I find that x equals 53. That means this bottom angle has a measure of 53. This bottom angle has a measure of 53. And the top angle was 53 plus 21, which is 74. Now the way it asks us, it says the 2 smaller angles are each, and we don't even have to do the degree angle, like they put the degree out there for us, we just write in 53. It says the larger angle is 74. So I don't love the way it's worded, but that's what it means. All right, we got 2 more. 2 more problems and we're all done. It says use a formula from geometry to solve for the unknown quantity. The length of a rectangle is 7 feet longer than the width. If the perimeter is 86 feet, find the length and width of a rectangle. All right, so it tells us perimeter and it tells us rectangle. So we need the perimeter of a rectangle equation. Perimeter of a rectangle, 2 times the length plus 2 times the width. That first sentence says the length of a rectangle is 7 feet longer than the width. That means we take the width plus 7. That's my length. The perimeter is 86. So that means we would have 86 equals 2 times the length plus 2 times the width. This is a system of linear equations. Ooh, excuse me, hiccup. It says length is w plus 7. So I'm going to take that and I'm going to substitute it into the other equation. That way I have a single equation with a single variable. So it'll be 86 equals 2 times the length, but length is w plus 7 plus 2w. If you make a mistake on this problem 9 times out of 10, it's because you forget to keep finishing the problem and you forget this extra plus 2w out here. Distribute to get rid of our parentheses. 2 times w is 2w, 2 times 7 is 14. Combine my like terms because I have 2w and 2w, give me 4w. Subtract 14 from both sides to get the w's by itself. 86 minus 14 is going to be 62 equals 4w. Divide by 4, divide by 4. And I find that the width of this rectangle is not that. 72. 86 minus 14 is 72. 72 divided by 4. That'll give me 18. Excuse me. Again, mental math. So the width is 18. So I'm going to go ahead and come over here. The width of the rectangle is 18. And it asks for feet, square feet, cubic feet. If you're doing perimeter, it's always going to be feet. Now, I know what the width is, so I know what my length is going to be because length is width, which was 18, plus 7. 18 plus 7 is 25. So it means my length of my rectangle is 25, and again, feet. We only use square feet if we're doing area. We only use cubic feet if we're doing volume. If we're talking about perimeter, it's just regular old feet, or regular old whatever the unit is for that problem. All right, last one, and I can tell that you can't really see that image. So I'm going to redraw the image down here so that you can actually see what it says. We have a river, and we have 1, 2, 3, 4, 5, and we have this. All right, so this is kind of the picture. Give me some grace. And obviously I made the river squiggly. They make it flat because you can tell a differentiation in the color of the picture. If I don't make the river windy, you won't be able to tell if that's the river, if that's the fence. And so I wanted to draw it this way. But what it says is it says a rectangular area is to be fenced along a straight river bank. So this is the river. I'll just write river over here. The length of the fenced-in area is to be 7 feet greater than the width, and the total amount of fencing to be used is 73 feet. Find the width and length of the fenced-in area. So again, this is a perimeter problem, but it's changed slightly. It's not a standard perimeter problem because we have all these subdivides, and because we have the river along this side. So this side over here, this long side, that's our length, okay? And our width is over here, but the width covers each and every one of these subdivides. So my perimeter equation has changed for this problem based on the picture shown. Instead of the perimeter of a rectangle being 2 times the length and 2 times the width, I have the perimeter being the length plus 5 times the width, because we're not going to fence in the side with the river. The river's over there. So there's my perimeter formula. It tells me that the maximum amount of feet I can use is 73. So that'll be 73 equals L plus 5W. And then it tells me the length of the fenced-in area is, so length is 7 feet greater than the width plus 7. Actually, what we just had above was the width plus 7, but our formula in our total fencing is completely different. But what we're going to do is exactly the same. We still substitute. Instead of length, we're going to have width plus 7. So 73 equals width plus 7 plus 5W. W and 5W equals 6W. Subtract the 7, subtract the 7. And we get 66 equals 6W. Divide by 6, divide by 6. And I find that the width is 11. So again, I'm going to go write that up here. The width is 11. And again, just feet. Not cubic feet, not square feet, just regular old feet. Now the length is going to be the width plus 7. So length equals 11 plus 7. Length equals 18. And again, just regular old feet. So in general, your perimeter problems are rectangle, so its perimeter is 2 times the width and 2 times the length. But if they give you a picture, you have to pay attention to that picture. This picture totally changed how the perimeter was gonna work because we only had 1 length and we had 5 widths. And so make sure to use whatever it is that they give you.